Hello and welcome to my YouTube channel. Today is the 25th of July, year 2021. Your host remains none other than David or Dave. And in this video, we're going to have a look at the monitor that I mentioned in the previous video when I was doing a review or basically a video documentation, proof, also disassembly guide for the 19-inch Mirai TFT-LCD monitor. Because I also mentioned in the introduction that I own another monitor whose backlight issue process is still ongoing. It's not fixed, it's not resolved. So in this video, I'm basically going to show you the issue that I still have with this monitor. So this is the Philips type that I also own. It's a 22-inch type. We're going to have a look at the label so that you can see the model. I'll probably already add it in the post-processing when I'll be doing for this video in the subtitles. This monitor is also another one that is a bit more demanding to fix, because with this one, none of the ordinary advices that you find on, for example, YouTube, how to fix the backlight issue, they don't actually work. So this is a bit more of a tricky fix. A little bit of a background story or how I came across acquiring this monitor. In the prolonged introduction for the Mirai 19-inch monitor, I mentioned the story that I had towards the end of 2019. If you haven't watched that section, you can go back and revisit it, but I think there's nothing wrong if I repeat the story a little bit also in this video, especially if you're a new viewer or a new subscriber and you haven't watched the previous video for that monitor. Well, anyways, towards the end of 2019, I met an interesting person through the website where I sell various things, from my household and the likes. And this person found my approach to writing ads or listings very likable, because he saw that I was really precise, honest. I made good pictures when trying to sell something, and he knew that I would make a perfect candidate for his business model of selling or basically assembling gaming computers. So he thought that we could go into business by, for example, acquiring old, outdated electronics or broken, fixing them, modding them, and then reselling them at a higher price and, of course, for profit. Well, anyways, one day he just simply decided to bring 10 or 15 of these TFT-LCD type monitors at my home. He just simply unloaded them. But now I think, thinking back, it must have been less than 10. So I'm a bit over exaggerating on the number 15. Well, anyways, amongst those monitors was also this Philips type, which I thought at that time when I was doing the testings that I would be able to fix it and of course keep it, because I liked it. Because amongst all the other monitors that he brought, this was the one that had a pretty good or big screen, and also the connections on the back were more than adequate. Those monitors that he brought, I think that very few had the backlight issue. I think only 3, maybe 4 had that problem. The rest were just simply, you could say, dead. They wouldn't even turn on. But anyways, I have pretty much therefore decided to give up on this monitor. I have lost all hope or faith of ever fixing it or finding the culprit that is giving me the issue with the backlight not turning on, because I have watched a lot of YouTube videos and read websites or forums what else you can look out for, what can be the reason for the backlight not coming on. So besides the replacement of the electrolytic capacitors that were bulged, leaked, and the likes, I went even beyond that. I wasn't able to find any cure or solution to this. Let's add further details on the organization of this video. Like I did with the previous 19-inch Mirai model or monitor, first I'm going to give you a couple of angle shots of the monitor itself. Then we're going to connect it to the laptop that you see on the right side of your screen. It's a Dell Inspiron 1525, so it's the one that, or basically whose issue with the charging of the batteries was resolved. If you haven't watched that video, you can have a look at it as well. So we're going to connect it to the laptop, and I'm going to show you the issue. Then we're going to take the monitor apart, have a look at the power board, where I think, in my opinion, the main issue with the backlight resides, so it's located. Then, you add some conclusional notes, and that's pretty much the end of this video. Okay, so let's go. So this is how it looks like, much more up close. On the lower right side, you have the button controls. They all work, by the way. So this is the model. We're going to have a look at the label on the back as well. Another sticker. The stand is also nice. It still has all of those rubber feet, so it doesn't slide on the table. You look on the side, or basically from the back, it has those holes that you can also mount it on the wall. Oh, this is the label. It comes with usual VGA and the DVI port. And on the other side you have the power connector and also another label. The stand is fairly easily removable. Basically the entire monitor, you just remove these 4 screws and you can start cracking. So the screen has been prepared in order for the experiment to begin. So I'm gonna plug it in into the extension cord. You'll see the Philips logo, or basically the picture, come on for a brief second, then go away. So yeah, let's do that. Yeah, so then you should get also the no input sign to appear. Underneath here, yeah, you have a very faint blue light. Now if I press the menu button, it should display on the screen. Yep, but it goes away, but it is present. I'm shining with an LED flashlight onto it, it disappears quickly. This also, as you can see, is present on the screen. Again, yeah, so definitely a backlight issue. Prepared the Dell Inspiron 1525 laptop, so the VGA cable coming from the screen has been plugged into the VGA port of the laptop. So now we're just going to turn it on, enter the BIOS, and then I'll try transferring or mirroring the picture onto the Philips screen. Pressing the F2 key, this is going to take some time to load, and we are in. I think that now we can already start with the experiment. I think I need to press the Fn and the F8 key simultaneously in order for the picture from the laptop to be displayed or mirrored onto the screen. Okay, did we get anything? Yeah, and then it disappears, but it is present there, so let's use the LED flashlight. Alright, let me show you. It's will be a bit more tricky to see. Yeah, I hope you can make it out. Yep. So picture is definitely present, so you could see the logic board of the screen is working fine. But the issue is, of course, the backlight. Okay. So you saw the proof. Now what we're going to do is simply I'm going to disconnect everything and we're going to take apart the screen. First we're going to remove the 4 Phillips screws that secure the stand onto the back plastic case. The stand has been removed. Now in order to pry the back plastic cover off, you have, as you can see here and on the other side, 2 small holes that you go underneath with a flat-headed screwdriver, and then you basically go all around the screen, because this one has locking latches that secure it into place. You might break some of them or many in the process, so don't let that worry you too much. This is basically just how it goes. You can be always very careful and you will break something, but it's not that crucial or important. We have managed to unclip all of the locking latches, so the plastic back cover just simply lifts off fairly easily. So this is it. This is how it looks like, the insides. Here you have 2 flex or 2 flat cables. One is for the operation of the blue light, the other is for, of course, the button controls. Here you have the wires coming from the CCFL tubes that are underneath, buried somewhere in the screen. Also on the sides, of course, naturally you have 4 of them. And here at the top you have the flex or flat cable going into the T-con board for the actual screen. So in order to remove the metal case, in order to extract the both 2 circuits, the power board and the logic board, you can really see it a bit here. You just need to unscrew these 2 Phillips screws. Here I already made some notes that possibly this CCFL tube could be bad. Interesting, I forgot about this. I'll keep this in mind. I also marked everything, how I connect everything up, so I don't mix up the wires or the connectors where each CCFL tube goes to. The separation of the metal enclosure, you could say, or caddy, has gone well from the rest of the metal case. Now let's have a closer look at the power board. So this would be your power board and the logic board. Now, in order to get this out, as you can see, we only have, again, about 4 Phillips screws that we need to remove, and also unclip this cable here that goes from the power board to the logic board, and then we can have a closer look. Finally, this is the power board. Now we can have a much more deeper discussion, or basically what I have done. You can already probably make out some things. All of these electrolytic capacitors that have a small black tick on top of the aluminum canister, all of these have been replaced. I think, if I remember correctly, only the bloated ones were located here, so these 6, but I replaced the rest as well. I can't really recall at the moment which strategy that I use, because when you're replacing the capacitors, you basically have 3 options. You can either replace them with the same voltage and capacitance, or you can go higher voltage, same capacitance, or even higher voltage and higher capacitance, because basically other components on the board limit how much current voltage is going to be passed on to these capacitors. In my opinion, is that you can go higher voltage and higher capacitance. Let's say, for example, that the original capacitor that was here, so the one that leaked, was bulged, so basically broken, that it had characteristics of, let's say, 16 volts, 470 microfarads of capacitance. And if I was to replace it with, let's say, a 25 volt and 1000 microfarads capacitance capacitor, that doesn't mean that the capacitor will be charged to those 25 volts and 1000 microfarads of capacitance. It will only go to 16 volts and 470 microfarads in total, because other components on the board limit that. That is, of course, taking into consideration if other components prior to being connected to the capacitor are fine. If they're not, well, that can cause a cascade of other failures of components located after the capacitor. To point out something else as well, I'm a bit of a, you could say, rat pack. As a hobby, I also desolder various boards, electronics, TVs and the like, so to have a nice stock supply of various components. So the capacitors that were originally bad on this board, they were replaced with, basically they were used, so they haven't been new. There's still a possibility that these capacitors, they're not good, and the issue is still, you could say, fixable by replacing these capacitors, at least 1 or 2. I don't know, because I do own a very primitive ESR meter or tester. I hope that you have seen my prior videos when I was testing some old capacitors with that unit. It's basically some sort of a DIY that my father made, but I don't have a proper ESR meter. I'm still saving money for those nifty gadgets that you can buy off eBay. Very useful. Planning on purchasing at least 2 or 3 of those. But anyways, it is still a possibility that these capacitors are not good, even though I have tested them on my primitive device. I'm recording this video onwards the next day, so the 26th of July year 2021, when the issue with the backlight still being in the off position didn't go away after replacing the electrolytic capacitors that were bad. I switched my attention to MOSFETs. That is because on a couple of websites and forums, YouTube videos as well, it was suggested that these can also be the culprits with the backlight issue. So I did some digging and I found out that these 2 are the MOSFETs on this board. Model wise, they're both the same. They are K3702. There's also another text written underneath, 8M3, but probably just the K3702 applies or is important. First, I tested these 2 MOSFETs while attached still to the board, so in circuit. It's great. You can actually see the text underneath, GDS letters. So that signifies which pin on the transistor is gate, which one is drain, and source. So that really simplified my testing. So I tested these 2 MOSFETs while they were attached to the board using the continuity or diode mode on the digital multimeter. But then also I have removed them from the board and repeated the testings. And to my surprise, or basically disappointment, they were both fine. So they were not broken or malfunctioning. However, still without a proper ESR meter or tester, I still cannot be sure. After that, you could say unsuccessful or not to my liking discovery. Do you think I was ready to give up? Of course not. I also decided to test these 2 components here. They're basically high voltage Schottky barrier diodes. I tested them, like I did with the MOSFETs, in circuit and off circuit. And again, these 2 are also fine or working. Brilliant. What did I do next? Well, I also decided, well, heck, let's test this component as well. It's a voltage regulator. This one, markings are LD111. 7AV33, and I tested this again as I did with the previous components, and again the results were positive. It works, it's fine, there's nothing wrong with it. By this time, of course, I was basically running out of ideas, getting a bit desperate as well. What components are still left on the high voltage side that could be giving me the problems? Well, we have this transistor here. I haven't tested this one yet, and there's also another one here. These two still remain, you could say, untested, but I sincerely doubt that they are broken. I'm more likely to suspect these two high voltage ceramic capacitors. The markings are 10J, 3 kilovolts. These are the only two components that haven't really tested out fully, and I actually think they could be the cause of the issue, because after that I have really honestly no idea. I was really most of the time under the impression if something is wrong with the backlight, it's usually located on the high voltage side of the board. This would be therefore the back side of the power board. This is the high voltage side. As you can see, this thick line separating the two sections. So what else could also be perhaps broken or not working on this side? Maybe this chip or integrated circuit. Maybe this is the culprit of my problems. The markings are, I'm using a flashlight and I've put a magnifying eyeglass in front of the camera's lens. Hope you can make it out. It's OZ99338GN, and underneath A86818.IN. So this can also be the culprit. However, as you can see in the vicinity, you also have a lot of what resembles a SMD transistor. So one of those can also be bad. Again, or also ceramic monolithic capacitors, the light brown components. Those also can be bad. Yeah, so it's hard to say. I have decided to take a second or a return look on the board, and I made some interesting discoveries. I noticed that basically this capacitor here, which is located near one of those high voltage transformers that drives the CCFL tubes, that it beeps. Yeah, so you can hear that it beeps. So it means it has to be in short circuit. Interesting. And also another capacitor beeps as well. This one here. Yep, and there of course you have also some of these, I think these are 0 ohm resistors. They beep as well, but I think this is normal. And also this one. And there are a whole bunch of these as well on the board. So 2 capacitors are definitely suspect. From this section onwards, I'm recording the 27th of July, year 2021 still. Yesterday, 2 capacitors that I showed you that were supposedly in short, so this one here and the one over there, they really kept me, you could say, sort of awake at night. So I decided to remove them and then still use the continuity or diode mode on the digital multimeter and check whether the situation changes after I remove them. And I discovered that it still beeps. I checked the capacitors and they were actually fine. So that is again an interesting finding. But I also discovered that specifically the points on the high voltage transformer, so in this case for this capacitor, that these 2 pinouts are basically still beeping. And on this side, these 2 contacts are sounding off. So that is interesting. I'm thinking that it is a possibility, nevertheless, that both high voltage transformers, the windings are in short. That's very not much likely, but it is a possibility, because I have also tried running the trace, let's say from this side or the opposite side, how everything goes. And basically both transformers are connected to each other. So if I was to remove one, it would be definitely interesting to see whether the beep still remains or not, or even remove both transformers, whether the issue remains. But I'm not going to go that deep. I'm just probably going to get rid of this monitor altogether. On the opposite side of the board, I also removed these two 3 kilovolt and picofarads, I think they are, ceramic capacitors, and tried checking them, but again, due to, you could say, equipment problems, I wasn't able to execute that test. So it's also still a possibility that one of those or both are bad as well. So this video basically does not have the anticipated output that I wanted, or the results. But not all is bad. Yesterday, when I did some just basic research, I stumbled upon by accident on AliExpress that you can actually buy this board, in a fully functional condition for something as low as, I think the price was somewhere around €7. Now that is a bargain, because I also tried looking on my usual internet marketplace, eBay. I found one, and then when if I was to order it from there, and then taking consideration having to pay our tax and the import procedure charging me extra money, nah. But still, is it worth fixing or getting a new power board, considering that this is a 22-inch type, and I did some research on my local internet marketplace website for how much they go for, and you could get them for low as I think 25 or 30 euros, and of course the price then goes up, and I'm talking about, of course, naturally used items. So is it worth fixing this monitor altogether? So that is something I have to consider, because I also recently, when I posted a question on another YouTube channel, I described my situation, and it was also suggested that possibly the board is fine, but the problem remains in 1 or 4 CCFL tubes, that at least one as such is bad or nearing its lifetime cycle. Because if the CCFL tubes are bad, that also supposedly locks the power board from turning them on. So that is interesting. So if I get a new board and I still have the same symptom, what did I achieve? I basically lost €10 and I didn't solve the issue. And I wouldn't be even able to sell, let's say, the old power board, which is broken, in order to compensate the costs for buying a new working one. Altogether selling everything at a profit. So that is a question. I have reassembled the screen, the Philips 22-inch TFT type. Everything is back in its place, all the screws, the clips, the circuitry naturally, and well, I've still connected it to the VGA port of the Dell Inspiron 1525 laptop, even though of course we don't have picture on the external monitor. So basically we're at the end of this video. Almost 1 hour ago, now it's almost 4 o'clock in the afternoon. It became quickly cloudy and the lighting changed in the room, so I had to turn on the light. Anyways, so whenever I set out to make a video, record something, document, I usually, even before I start, I have a solution prepared to a problem that is present, but not with this video. So no solution as such was offered in terms of fixing the issue by removing components on the board. The issue with the backlight remains unsolved, even though I did very comprehensive, detailed analysis, research on what could go wrong. I replaced the capacitors, electrolytic that were bloated or bulged, leaked, and that didn't fix the problem. I also tested the MOSFETs, they were fine. The voltage regulators, the Schottky high voltage barrier diodes, no success. Of course, I ran into some other issues with equipment, not being able to test other components. But I think it's still useful that I recorded, you could say, my thinking process, as it might serve other people how to diagnose their broken or not working TFT-LCD monitors or even LED TVs, what to look out for, what can you check. Nevertheless, I still hope that you have found this video somewhat informational, that you learned something new. If you have any questions, suggestions, perhaps even guidelines on what to check next, or if I have missed anything, let me know all that down below in the comment section, which is always open and you're invited to a civil discussion. If you haven't liked the video yet, please do so. If you want to share it, I have no issues here. If you're a new viewer, please subscribe. If you're an existing subscriber, well, thank you for staying with me so long. Today has been the 27th of July, year 2021, and hope to see you very soon in another tech-based video. This has been David or Dave. Goodbye.